Number 17 says, what trigonometric ratio has the same value as cosine of 48? A trigonometric ratio is basically two numbers, one over the other. One number on the top represents a certain side length over another number. So for example, when we use SOHCAHTOA, and let's say you were given enough information for opposite and hypotenuse, when you put that opposite over the hypotenuse, that's a trigonometric ratio. And so it's just basically a comparison of two numbers. When you're using a calculator, if I put the cosine of 48 in, watch this. So the cosine of 48, it's giving it to me in decimal form. It's basically taken that fraction from before and gone ahead and divided it. So it's kind of hard to figure out what that fraction would look like in terms of what number over what number. What we're looking for is which of these has the same value. Now, I'm going to show you a shortcut to this, but then I'm going to explain why it works in just a minute. So if we're trying to find the same value as cosine of 48, what we might want to do is just go ahead and plug each of these in. Tangent of 48. Are those two numbers matching? No. We're looking for something that's like 0.669. Let's try sine of 48. Is that 0.669? No. What about the tangent of 42? Is that 0.669? Not a chance. And then one more. Sine of 42. Is that 0.669? It is. So we know this is our answer choice. But let's talk about why. I'm going to go ahead and draw a triangle here. And I'm just going to do the traditional 3, 4, 5. Because if I use Pythagorean theorem, these numbers would make a right triangle. And I'm going to call this A. And I'm going to put theta here. So if we're working with this, and by the way, this theta is not equal to 48 degrees. We'll talk about this relationship in just a minute. But if I was looking at this theta here, and I was doing the cosine of it, because that's what we started with, was the cosine. Cosine of this theta would be the adjacent over the hypotenuse. So cosine of the theta would be the adjacent over the hypotenuse. And what we were trying to find was something that had the same ratio as that. So we want something else to have 4/5. Well, another way we could get that is if we put something here like B, and we wanted to do B, and look, if we went opposite over hypotenuse with this angle B, that's known as sine. So sine of B would be opposite over hypotenuse, and it gives me the same thing. And what we were working with were these two particular angles. Well, they're your two complementary angles inside the right triangle, the two angles that add up to be 90 degrees. So the relationship that we have here, okay, let's get rid of these side lengths. But originally you were given cosine of 48 degrees. That was going to have the same measure as the sine of this one right here. So when we do 90 minus 48, this is 42. So the cosine of this angle was the same as the sine of this angle. And again, what I want to point out is there will always be a relationship between sine and cosine. These two angle measures here are your two acute angles inside that right triangle. They should be complementary. That means this plus this should equal 90. So I never actually had to put each of these into my calculator. What I could have done is I could have said, I know that if I've got a cosine, that matches to a sine always. There's that relationship. And if I just had done 90 minus 48, I would have found I had 42. And automatically I would have known that that was the same as sine of 42. It works for anything. For example, I could say sine of 50 degrees. What's that have the same trigonometric ratio as? Sine is buds with cosine, and 90 minus 50 is 40. So it works anytime sine and cosine go together, and basically you're just taking 90 minus whatever this angle measure is, and those two will always be equivalent.